Okay, the first video of 2016. We're here in chemistry. IB, chemistry, 11s. We're doing topic 5. And the name of topic 5 is energetics and thermochemistry. Okay, now, the first thing I want to do is talk about hot and cold. What is hot and what is cold? Now, when you talk about the environment, when you talk about endothermic and exothermic, it's an object. You got to know your terms. It's the object relative to the environment. That's what we talk about endothermic and exothermic. It's the object. The object can be a chemical reaction. It could be a rock. It could be a fire. It could be wood burning. But it's the object that's either giving up or accepting the heat other than the environment and the environment. It's an object versus the environment, okay? Now, so the first thing I want to define for you is what is hot and what is cold. Munkel, what does the word hot mean? Well, listen carefully because people think they know what this word means and they struggle with it. And I'm giving you a play-by-play. Munkel is kind of like, squinting his eyes a little bit. He's about to scratch his head. He's not sure. One of the brightest kids I've ever taught is not able to explain the word hot quickly. Portium, what do you think?
High temperature.
High temperature. That's it? High temperature? Is the temperature of your body high relative to an icicle? Is it? Does that icicle feel hot or cold? Feels cold. So high temperature, is that hot? Does that mean hot? Well, you got to add some words in there, huh? What else do you think? What does the word hot mean? To you, the word hot. See, the word hot, let people at home are like going, who cares? Well, I do. So let me just do this painlessly. The word hot and cold is really a human thing. We feel, when I say hot or cold, that's what we feel, correct? Okay, so here's the skin. That's skin, right? Here's an object, right? So the skin, in this case, the hand, the skin, the body, the face, the feet, that's the environment that we're talking about. Yes? So this is the environment. Here's the object. This is object, and this is the environment, correct? Now, when does that object feel cold? What's happening? When that object feels cold, what's happening relative to heat transfer? Is energy leaving the hand, the body, or is it going into the body when it feels cold?
Leaving.
Yeah, it's leaving the body. Energy travels from high to low concentration. Correct? That's how it travels. So if it's high concentration here, it's going to go into here. Let's say that's an icicle. Could be a piece of ice. Could be anything that's really cold. This is called cold. Cold, the word cold, is a human word that means that energy is crossing the membrane barrier out of the body. It feels cold. Correct? When does something feel hot? Define the word hot for me.
When we're gaining energy.
When you're gaining energy. So if this were hot, it would pass like that. That feels hot. Correct? Yes or no? Right. If you have too much hot, what happens?
You get burned.
You get burned. What is a burn? What does it mean, burn? I'll tell you. You want to tell me or not? No, we're going too quickly, I know. People are saying, no, you're not waiting long enough for the answer. What does it mean, the word cold? What does it mean, the word hot? When you get a burn because it's too hot, what does that mean, a burn?
It means cells have been destroyed.
Cells have been destroyed. How? They've been dehydrated. You take all the water out, correct? Correct? Yeah, they've been dehydrated. right? That's a burn. What happens when it gets too cold? Is that a burn?
Kind of, because like if you touch dry ice, then it burns you.
Yeah, but so what is, all right, so what's a burn? What did I say a burn was?
Like dehydration of the cells.
Dehydration. So if you have water in your cells and it turns to ice, is that a burn? Why is that a burn?
Because it's not liquid water anymore.
It's not liquid water anymore. It's solid water. So you're dehydrating. You're taking the liquid water out of the body. You're also destroying the cells. Why? Because the ice is jagged and it just rips the cells apart. So you're killing the cells. Correct? So what is the difference, especially on how it feels, of a cold burn versus a hot burn? What's the difference in terms of how it feels? Anybody? They don't get out much. That's okay. Anybody ever have a cold burn? Frostbite in the mountains? I know we're in Cambodia. It's difficult. That's okay. Has anybody ever seen snow? Porcium, have you seen snow? Porcium has never seen snow. Munkel, have you seen snow? Munkel has never seen snow. Lauren, have you ever seen snow? Okay, so you've been in areas where you could actually get a cold burn.
Yeah, but I was like always pulled back inside before I like ran.
Protective parents. That's very good. Excellent. Excellent. So 2/3 of my class, I only have 3 students here today, have never seen snow. So it's difficult to get a cold burn. But let me tell you the difference between a cold burn and a hot burn in terms of how it feels. You ready? This is the difference. Absolutely nothing. When you get frostbite, or maybe it's going to frostbite and it's not frostbite yet, the pain is so intense, it's outrageous. It's unbelievable, the pain. Unbelievable. My daughter got frostbite one winter and we took her to the emergency room and they just let her sit there because there's nothing you can do. The feet just have to thaw out. I took her home, I made her sit on the side of the tub and I put her feet in cold water, warm water. I slowly increased the temperature, very slowly, so that otherwise it would be hot to her. It would be too much heat too quickly. And so she finally started to feel better, but it took a long time. It took a long time. And she was in agony, absolute agony. So which one relative to the environment, remember your hand's the environment, would be endothermic? Which one is endothermic, hot or cold? Remember, you're the environment. Of course, you got to look at the board, not at the desk.
Hot?
Which one? Hot is endothermic? Now remember, it's always relative to the environment.
Yes, because exothermic is when it leaves, so that would be cold, so hot is endothermic.
No, opposite. In other words, it's relative to the object and the environment. In other words, you're losing, the environment's losing the heat. So the cold is going to be endothermic. It's going to feel cold. A chemical reaction, right? A chemical reaction is going to feel cold when it's endothermic because you're getting heat out of the system, correct? And it's going to be hot. What's a great example of an exothermic reaction? Great example. Where you're putting tons of energy into the environment. Remember, your hands, here's the environment. What object gives you incredible heat?
Fire?
Oh, there you go. Good girl. Fire. Fire is the ultimate exothermic, right? So fire will give off tremendous heat. Burn your hand, cook it. Okay, use a little curry. Tastes just fine. Okay. So that's what this is the idea of exo and endothermic. When we talk about exo and endothermic, it's normalmente relative to the human condition. What do we feel? You'll be in a laboratory doing an experiment. You put ammonium nitrate in water. It's going to feel cold, right? So what is that? Is that heat of solubility, heat of solution? Is that going to be endothermic or exothermic if it feels cold? It's going to be endothermic, remember? It's endothermic. It's always relative to the environment. When the environment loses heat, it's endothermic. Okay? End of hot versus cold. Let's keep it simple. We'll go on to another one. Yes? Okay, good.